Hello there. Now this is the concluding part of our lesson on elements, compounds and mixture. So we are looking at elements, compounds and mixture 2. Now moving along, the objective of this lesson is to help learners define mixtures giving examples, describe the types of mixtures giving examples, and describe the various methods of separating mixtures. Now, what are the types of mixtures that we have? A mixture contains two or more constituents which are physically joined together. There are two types of mixtures. We have homogeneous mixtures and heterogeneous mixtures. Now, homogeneous mixtures are the type of mixture in which two or more compounds mixed are distributed uniformly throughout the mixture. For example, we have air and saline solution. Whereas heterogeneous mixtures are the type of mixture in which two or more compounds are mixed unevenly or unequally. For example, we have oil in water and sand in water. So you can see these are examples of homogeneous and heterogeneous mixtures. Homogeneous mixture, we have cereal. Homogeneous mixtures, yes, there's a mistake. Homogeneous mixture, we have steel, rain, wine, air. While heterogeneous mixture, we have cereal, ice and soda, soil, and blood. Moving ahead, we'll be looking at separation of mixtures. Now, the process or method of separation of different components of a mixture by physical method is known as the separation of mixtures. Now, the choice of techniques of separating mixture depends upon the mixture type and difference in the chemical properties of the components of the mixture. Now, you have various types of mixture here and the separation methods that are that can be used to separate these mixtures. Number one, we have a mixture of insoluble solid in a liquid. So the separation methods that one can use are filtration, decantation, and centrifugation. Now, the type of mixture in which you have soluble solid, to separate soluble solid from a solution, we can use the methods evaporation, crystallization, fractional crystallization, and precipitation. To separate solvents from a solution, we use distillation. To separate miscible liquids, we use fractional distillation. When we have immiscible liquids, we use separating funnel. When we want to separate solids of different sizes, we employ sieving. When we want to separate mixtures of solids which sublime from other solids, we use sublimation. Now, mixtures containing magnetic substances from non-magnetic ones, or magnetic solids from non-magnetic ones, we use magnetization. And if we want to separate solutes from a solution, we use chromatography. Now, moving ahead, we'll be looking in detail the various methods of separating mixtures, and we have quite a number of them that we'll be looking at today. This is not an exhaustive list, but this one is definitely the one that we are going to be paying attention to in this lesson. We'll be looking at sieving, evaporation, distillation, filtration or sedimentation, magnetic separation, separating funnel, and finally chromatography. So we'll be looking at them in detail. Now, number one is sieving. It is used to separate mixtures containing largely different sizes of components. The mixture is filtered via the sieve pores. All of the tiny compounds pass through easily, but the mixture's larger components are trapped. We'll be looking at the picture in the next slide. Now, evaporation is a type of technique for separating a mixture, most commonly a solution of a solvent and a soluble substance. In this technique, the solution is heated until the organic solvent evaporates, converting it into a gas and predominantly leaving behind the solid residue. Now, in distillation is done when a mixture contains two or more pure liquids. The constituents of a liquid mixture are evaporated, condensed, and isolated here. When the combination is heated, the volatile component vaporizes first. The vapor is collected in a liquid state after passing through a condenser. Now, in filtration or sedimentation, Filtration is the most common method of separating a liquid from an insoluble material. Take for example a sand-water mixture. Filtration is employed to remove solid particles from the liquid in this case. Various filtering agents such as filtering paper or other materials are commonly utilized. Sedimentation is the process through which heavier contaminants in a liquid, often water, settle to the bottom of the container carrying the mixture. It takes some time to complete the process. Now, in magnetic separation, when one of the substances in the mixture has magnetic properties, this approach is quite useful. To separate magnetic elements, strong magnets are usually utilized. In using separation technique or separation funnel, a separating funnel is primarily used to separate two immiscible liquids, for example, oil and water. The mechanism works by exploiting the uneven density of the particles in the mixture. Using this procedure, oil and water may be easily separated. And finally, we'll be taking a look at chromatography. In this separation technique, we separate the mixture components by passing them in the solution over a medium in which the mixture components move at different rates. This technique is dependent on the various properties of compounds present in two phases, that is, the mobile and stationary phases. Okay, now we'll be looking at these separation techniques one after the other using this picture right here. Now we'll be talking about the separation technique, filtration and sieving. Now, from the explanation that we made earlier, if you have a mixture of sand and water, which are both liquid and solid mixed together, now we use the different states to separate the liquid from the solid. So this is the setup. You have your setup, which contains a funnel which channels liquid into the container. We have the filter paper, which is semi-permeable, which separates the solids from the liquid. So when you pour your mixture of solid and liquid into this funnel, into the filter paper will retain the solid, which will be the residue, while the liquid will pass through. Now, the liquid that passes through, which does not contain the solid, is called the filtrate. The filtrate here is liquid that has passed through filter paper, while the residue is the solid particles trapped by the filter paper. So at the end of the day, we've been able to successfully separate a mixture of liquids and solid that do not dissolve. As you can see here, let's assume that this is sand. The sand does not dissolve in the liquid. Now, moving on to sieving right here. Now, we sieve mixtures which have varying particle sizes. So if you have various mixtures of substances with various particle sizes, sieving is very good for this. So let's say you have a mixture of sand and gravel right here. So what happens is that sieve is the one that we use in this sieving method. So this sieve is used to separate wanted materials from unwanted materials. So what do? We pour the gravel into the mixture of sand and gravel into the sieve right here. So what happens is that while we shake the sieve, the gravel, because it's larger in particle size, will stay in the sieve, while the sand will come out through the pores from the sieve. You see, so this is what happens here. So once you shake the sieve together, you see the smaller substance with smaller particle size will go through the pores, while the larger one will remain. So this is the sieving technique. Now, moving on, we'll be looking at evaporation. Now, as you see in evaporation here, what happens is that we use this to separate a mixture of solid and liquid. In this case, the solid dissolves to form a solution right here. As you can see, the mixture here is a solution of solid and liquid. So what happens is that we use a Bunsen burner, to heat up the substance. This is a gauze mat, and we have a glassware for evaporation. So what happens is that, for example, salt and water solution. So once heat is applied here, the water evaporates, it forms vapor, leaving the salt behind, and because the salt does not dissolve in heat, so at the end of the day we get a dry salt while the water is evaporated. Now in the case of separating mixture using magnets, if you have a mixture of sand and iron filing, magnet or magnetic separation is used here. So you have a magnet here which is used to separate the iron filing. So the iron filing, which is a magnetic material, will be attracted to the magnet, you see, so leaving the sand behind. So the iron filing is attached to the magnet while the sand is left behind. Now moving on, we have distillation. Now distillation, as we described, is used to separate two pure substances, usually mixtures, miscible liquids, which have different boiling points. So this is the setup right here. We have the Bunsen burner, we have the liquids with different boiling points. Over time, the one that is more volatile of the two, will vaporize out, passing through the condenser. While the condenser will condense the liquid, it will turn the vapor into liquid by cooling it down, and we collect the condensate into this flask right here. This flask receives it, leaving the one that is less volatile here, you see. So that is how normal distillation works. This is set up for normal distillation. Now in using separating funnel, we use it to separate immiscible liquids like oil and water. So this is the setup. We have a funnel, we have a separating funnel, you have the stopper, we have the stand. So what happens is that the mixture of oil and water, what is poured here, because of their separate densities, water is heavier than oil, so the oil will go at the top of the mixture here while you have the water below. So all you need to do is just to open this cork and the water will come out. Then once it's about to get to the oil, you just close the cork back, then you have your oil and water separately. Now moving along, this one wasn't mentioned, but I just felt that I should add it. So this has to do with the sublimation technique. Sublimation technique is usually used to separate ammonium chloride salt, you see, from other substances. So one substance sublimes while the other one doesn't. So what happens is that once we burn this mixture, what will happen is that the ammonium chloride will turn to vapor, and once it gets here, it cools down and it turns to solid. So what happens is that it will precipitate here, while the other substance that doesn't sublime will remain here, right here, separating the two mixtures. Now finally, this is an example or setup for chromatography. For instance, if you want to separate the components of ink is a mixture, and you have this setup here where you have the solvent, you have the filter paper where you pour the ink into. So you have a line here which shows us that this is the starting point of the ink, and once this paper is put inside the liquid, the filter paper will soak up the liquid. So as it's soaking it up, moving up the paper right here, the various components of the mixture will move at varying speeds, and as you can see, the filter paper absorbs the solvent, and chemicals are separated because different chemicals travel at different speeds. So you can see you have various components, going up the filter paper at different speeds and at different rates. So that's it. That brings us to the end of our lesson for today. Let's take a quick look at the summary. A mixture contains two or more constituents which are physically joined together. There are two types of mixtures, homogeneous and heterogeneous. The process or method of separation of different components of a mixture by a physical method is known as separation of mixture. The choice of techniques of separating mixture depends upon mixture type and difference in the chemical properties of the components of the mixture. And this brings us to the end of our lesson for today. Before we go, I want to pause this video and answer the questions that you have right here to see how much of the lessons that you have learned. And please share this video, like and subscribe to my channel, and I will see you again in the next lesson. Bye bye.